This is Inspiring Design, where unique innovators come together to share their knowledge, share their insight, and keep us up to date with the latest industry trends. And here's your host, Roshan Senanayake.
What's up, listeners? Welcome to Season 4 of Inspiring Design with Roshan Senanayake. This is where the best of the best brands, experts, change makers, and thought leaders come together to share their valuable insights, experience, and knowledge, all centered around the growth sector in advanced manufacturing within Industry 4.0, encompassing various industries, technologies, skills, knowledge, trends, as well as stakeholders, all the while linking it back into education within schools and universities. I'm here with Govinda Pandey, a very special, very smart and analytical man himself. He is the CEO of Rockfield, co-founder of LiXiA, and adjunct professor at James Cook University. His leadership and innovation approach has resulted in Rockfield and LiXiA pioneering the adoption of modern sensor technologies to accelerate the world's transition to safe and intelligent infrastructure. Govinda's network extends globally through his training and business collaborations in Japan, China, North America, Europe, and South Asia. As an industry thought leader, Govinda developed and delivers his talks at seminars, conferences, both nationally as well as internationally, as a guest speaker on a number of different types of platforms. He also sits on multiple advisory boards in engineering and academic sectors. He is a passionate advocate about applying the digital skin to infrastructure assets to improve public safety and sustainability of our built environment. He's one of the considerable amount of times mentoring business leaders, schools, and university students to inspire the future generations of leaders. He's the perfect man for the job, so let's get straight into it. Govinda, welcome to Inspiring Design.
Thank you.
Can we start off with a little bit of background on yourself? What's your story?
Look, I was born and bred in Nepal. And when I was 18 years old, after my high school, I went to India to do my engineering, civil engineering that was. And I returned back, and after that, I went to Thailand to do my master's. And then I got an offer to do a PhD in Japan. So I spent 5.5 years in Japan doing PhD and postdoc. And then I had to get to an academic position, and I applied at JCU for a lecturer position, and I got an offer. So then that brought me to Townsville.
Wow. So you've actually had the opportunity to work in many different countries and most importantly, educate yourself in many different countries. Do you think that has had an impact on how you work today?
Absolutely. It is more around sort of that broader worldview and around sort of cultural awareness and all that really helped shape my thinking and the way I behave, act, and perform as a leader.
Awesome. And so what happened after you come to Townsville and worked in JCU? How did you get into the industry and to do what you're doing now?
Look, I did that lecturer gig for a couple of years, and I quickly realized that I was sort of more interested in hands-on engineering work. Yeah. And also, in academia, there's a lot of focus on getting competitive research grant and all that, so more around the discovery area. Yeah. And the success rate of that is very, very low, and you spend a lot of time putting a grant together, application together, and then just to find out that it's too hard. And again, I was always fascinated by the translational outcome of research and impact. So that's why I decided to actually move on and get to the industry.
Yeah, awesome. And I believe you were involved with the founding of Rockfield. Is that right? Or what's the story behind Rockfield?
So Rockfield is like a entity spun out of James Cook University. That's why we're here in Townsville. Rockfield now, we've got around 25 staff. We've got offices around the country. We're headquartered here in Townsville. And we've got branch offices in Melbourne, Perth, and developing one in Brisbane at the moment. It was spun off 21 years ago. I was not part of the founding team. I joined 10 years ago. But the way Rockfield was founded was that, back in late 90s, what we call digital twin these days, like, finite element modeling or computational mechanics of structures was quite new, those techniques. And our founding director, Jeff Loughran, so he was trying to solve some very complicated sugar industry problem, because we've got a big sugar industry here up north. And he found that a tool or a solution in Wales and in Swansea. So Rockfield has got nothing to do with rock. Rock came from three founders of a software company in Swansea. Roger, Owen, Cedric, and Ken, and they were working on a mathematical field problem. So
makes sense.
Yeah.
Awesome. And so I want to actually get into discussing exactly what does engineering look like now, especially within advanced manufacturing and so on. But before we get to that, I just want to understand, what did your industry look like, let's say, 20, 30, 50 years ago, especially because from my own personal point of view, coming from an architectural background where supposedly we don't get along with engineers, but my experience has been very different. Even from the first day on working in a firm was very different engaging with engineers. So I'm not sure where that myth came about, but so how did your industry actually look like in the past?
So mainly, if you look at like structural engineering industry, like just engineering is very
very vast. Yeah.
Let's just focus on structural engineering. If you look at 50 or 100 years ago, like we had very talented structural engineers, like and everything used to be done like from first principles, hand calculations, and all the drawings used to be done on the board, like all
prior to CAD.
Prior to CAD, all manually done.
Yeah.
And look, we've got structures like Sydney Harbour Bridge. Are we designing and building similar sort of bridges now? Of course not. Apparently we can't afford structures like that. But those are the sort of things that inspired a lot of engineers, future engineers. So fast forward to today, like now we've got a lot of powerful tools. So whether there's a computer-aided design or even in numerical design, and got software to do a lot of things. So we've advanced quite a lot, particularly if you're looking at from the design side of things. But we've lost a lot of fundamental touch. To engineering, so we're not doing things from the first principles anymore. So if a software spits out something, we sort of tend to believe
go with
that. So I've got a little bit concerned with that. So that is in the engineering area, but we're really advancing with the technology and BIM, building information modeling it's a thing that's going to disrupt the design and construction industry as well. So what we call digital twin. So it's quite exciting times. But when you look at the application of sensor technologies and IoT, sadly, our industry is a laggard. So if you look at bridges built in Roman times, and if you compare with like automotive industry, like the cars, a few hundred years ago, and cars now, so sort of cars can self-drive and everything. But if you look at our infrastructures such as bridges, they were dumb back then, and they're dumb right now as well, and that is not good enough. Yeah,
so this is in that transitional point almost where whatever that looks like is happening now with these, aided by these different technologies. What do you think it'll look like in the future? Just speculation,
Look, I think what we imagine structures to be in the future, like just just look at the some of the disasters, the recent ones. Even a couple of days ago, there was a bridge collapsed in Mexico City, and killed, tragically killed 20 odd people, and 70 odd people got seriously injured.
Wow.
And we just don't know. We are now living in such a dense built environment at the moment, and even the building that we're in, sort of the roof above us, whether it's in a good state or not, we just don't know.
We don't know. Yeah.
And the only way that we have been managing the integrity of the existing assets is by periodic visual inspections.
Yeah.
And a lot of things are hidden. We can't see. And
very true.
So what we imagine in the future is like, all these assets, physical infrastructure, the built environment, would have a digital skin. Mm-hmm. By that, what we mean that, using this sensor technologies, big data, and the power of artificial intelligence, with the overlay of that into our built environment, and that enables the built environment to communicate with society. If they're feeling hurt or they're in distress, they to talk to us. But not only that, if with the digital skin, it will also look at the environment. So with the adoption of technology, we imagine that in the future, like there will be a harmony between built and natural environments.
Yeah. I think that's amazing. This is just, I'm spinning with ideas in my head right now, and I think it's one of those futuristic movie situations where, for example, if there's a flood or fire, if it can actually speak and sense with the existing environment, the capabilities of that and what it could actually do, especially with being able to give early warnings and saving lives, or even avoiding a lot of damage, maybe risk mitigation techniques could actually be implemented. So this is awesome. I feel like future things, and I feel like eventually the building will lance itself off the ground and then fly away and replant it somewhere else. But so how does this look like in terms of implementation? Obviously, engineers now, this sounds very labor intensive, and you need a lot of technical knowledge as well as technological understanding. What does that look like? What are the key skills that people are going to need in the next 5, 10, 20 years?
Look, it's picking up on your comment just a little while ago. Like we, Rockfield, we sort of worked with James Cook University, and we spun a new company off, a tech company called LiXiA. LiXiA stands for Living Infrastructure by Informatics and Analytics.
Love it.
Being engineers, I can't help it. So what we're doing there is like actually we're designing like IoT devices and implementing that primarily to start with the utility industries with utility poles. If you look at like timber poles in the energy distribution industry, if you look at just Queensland, they've got 1.7 million poles. And they are spread across 192,000 kilometer long network, and that is a 70-year-old network, and the timber poles can rot and can be attacked by termites and all that type of thing, and physical inspection every 4 years, it's not possible. Not possible. It's not enough to properly manage them, and also that grid is designed primarily for a directional flow of electricity. For example, like you've got a power generation somewhere, and then you transmit power, and then you distribute to the network. So that's the directional flow. Yeah. But now with the solar power and renewable generation, so now everyone's got solar panels on their roofs, and they're squirting power into the grid. And the grid is not designed for that bidirectional flow of electricity. So what that is doing is sort of creating spike of electricity into the grid. So then the conductor wires can heat up and can sag more than what it was designed to do. So
makes sense.
So that's why it's becoming very, very complicated. So our technology is actually to utilize IoT artificial intelligence, image recognition, and big data to help address that problem. But then, like when we're doing that, I just wanted to connect that one to the disaster resilience side of things. So imagine like all these poles around, whether it's street lights or utility poles, if they've got an IoT device in there, and if that can sort of measure the water height above road in a flood situation.
Yeah.
And with the data analytics and data visualization, that information can be quite powerful for disaster management team to see where the water is rising in real time or near real time, and how to send messages to people and how to evacuate, where to evacuate, and all that. You can do that sort of on near real time basis, which you can't do it at the moment.
And I think I'm sensing this pattern across all of these different types of industries within advanced manufacturing is the consistent amount of real-time information communication and sharing of that. And I think the implications of that at this massive scale, that's where the biggest, I think, game changer is. And if the accuracy of these things are, from what I've understand, very, very different to the mapping techniques or data gathering that we used to do. So that's amazing. That's awesome.
So now, sort of back to the skills requirements.
Yes.
I think with universities, we just got to revisit our curriculum a bit, because obviously traditional engineering stream, so they're sort of you got only 4 years. You got only so much time. You got to cram everything into that so that you give that breadth to the students. But I think what we need to add is we just need to add those, technological sort of subjects into that as well. And it doesn't need to be very deep. Like at least we want our graduates to be equipped.
So they're familiar with it.
Yeah, exactly. And the possibilities of the technologies. So once they get to the workforce and when they start encountering issues and challenges, then not only they'll look into the traditional solutions, but they will sort of, explore opportunities with modern technologies, and that is what we haven't done well over a long period of time. But civic leaders and industry leaders will have to sort of work with universities to try and drive that change.
Do you think that things, for example, you mentioned building information modeling before. I'm quite familiar with it because of the architectural industry. And however, though, one of the things with things like technologies like BIM is that the learning curve is very, very long. And sometimes it's, upwards of 10 years just to be able to manage something of that sort. So if that's the case with these types of elements coming into engineering, which is already quite a knowledge-intensive, technical, and very little room for error, do you think the training needs to actually begin in a high school level rather than just in tertiary?
Absolutely. And we just got to start from primary school.
Yeah,
I think
love it. That's awesome.
That's where we got to start. And I see a lot of focus on STEM or STEAM or whatever you call it in the school, but that hasn't resulted in the numbers. Enrollment numbers in the universities. So I sit on the JCU engineering advisory board as well, and we sort of discussed that one in length in our previous meeting. So I think what is lacking is the industry, like high tech industry. So when we spend a lot of time with the primary school and high school students, talking about robotics and AI and augmented reality and all the sorts of things, if they can't go to a workplace and see that technology in action, so then they won't be able to connect with that, and it's very, very hard to build that purpose and say, like, look, this would happen in 10 years. We're teaching you for 10 years. That's not there. But that's not the case. Like, there are companies, there are pockets of things that's happening around, and if we can bring kids to the workplace to see how that technology is impacting lives, it's solving societal problems.
Yeah, so more industry
challenges.
exposure
Yes.
at a younger age as possible.
Exactly, 100%.
Now, engineering compared to at a Queensland and Australian scale, we can look around and almost get a feel for where things are at. But compared to the rest of the world and other countries, where do we sit in terms of these adoption of technologies and the implementation of it?
Look, given that I've got exposure in both industry and academia, when I look at Australian universities, our universities are fantastic, and we've got some really bright academics, young and matured, sort of working on some really fascinating areas and really pushing the boundaries. But what is lacking here is that bridge between industry and academia. And, and if you look at industry over here, we don't spend a lot of effort into R&D. So we like to sort of get immediate outcomes and off-the-shelf products and all that. So
quick fixes.
And when you look at academics, they're doing some some really cutting-edge work. But the people in the industry, they sort of go to the websites and try and find off-the-shelf solution in Europe or North America and all that. So we just got to change that and start bringing university and industries together, and also along that journey get schools and vet sectors and everything involved, so that that visibility is there, and so that we can inspire our future generations.
I love that. I think that's very valuable advice for any listeners, and we usually get most teachers listening to it from a school level, and think, what's your advice for them if they want to take on this type of things at a secondary education level? What's your advice for the teachers?
I think for the teachers, first, teachers got to get inspired. So
I like that you threw in the word inspired.
Yes. And teachers, and it's been on us, people from the industry as well. So we've just got to reach out to high school and primary school teachers, so that we can share with them what exactly are we doing at the minute.
Yeah.
Using technology to impact lives and to change, improve or solve societal problems and all that type of thing, so that they can then take it on to forward to the students, and also the people in the industry will have to have open days and things like that, so that we bring students in and interact with them, so that they can find the purpose in utilizing their...
So almost like both sectors actually need to open their doors and reach out and shake the hand a little bit. And I feel like a lot of the misalignments and the knowledge gaps and skills requirements can actually bridge over that. But one of the main misconceptions that we get, especially with engineering, is the misunderstanding on how this actually classifies as a part of advanced manufacturing. A lot of people think it's a separate industry. It's part of AEC, the construction industry, not entirely in manufacturing as such. What's your opinion on it, and how do you think it classifies under advanced manufacturing?
So that's a really good question. So what's happening now is the problems or the challenges in the construction or manufacturing or mining industry. To solve them, we need bespoke solutions to address those problems, and a lot of that is to do with the IoT solutions and hardware and software and all that type of thing. And you got to build that one somewhere. You got to manufacture that one somewhere. So that's why, like with our new spin-off LiXiA, we decided to take on manufacturing ourselves. So we're sort of doing some tinkering and some prototyping at the moment. But if once we get a large order, then we got to manufacture them, right? So and that is what we believe is the future of manufacturing. Obviously Australia as a nation, we won't be able to compete in mass manufacturing of commodity products. We just can't compete.
Yeah.
But with the high end bespoke, low volume, high value products, I think we are much better off manufacturing things here using Industry 4.0 technologies. And if Germany can do that, why can't we?
Absolutely. And I think that's a brilliant question to prompt the minds of anyone involved in this sector. So how does this actually, what's your advice for, I think, if we're stepping back now towards the actual students, if they're looking at engineering as one of their preferred career paths? One of the questions that we always asked is, it's a little bit transitional from the previous Industry 3 requirements, but what are the softwares that they need to learn?
I think like there would be discipline-specific software and all that type of thing, but what I'm finding is that even engineering graduates with some form of programming skills, particularly now, we're sort of in the we talk about data lakes and all that type of thing. We're in the big data world at the moment. So anyone with some sort of Python or that type of data management or R or MATLAB and things like that, they will have that edge. Good.
And how does the relevance of CAD, some sort of whatever this discipline-specific CAD information, their competency on that, how important does that place when they're looking to be entering into an industry?
So that's quite important as well. So these days, we don't call draftees or draftsmen or draftswomen these days. So we call them designers.
Yes.
So what now, and some of the engineers do that as well. So so that's becoming a new profession, if you will. And these days, with Gen Z or millennials, and they're sort of they grew up with technology, so everything is quite intuitive for them, and they excel really well. So just to give you an example, we've got a technical college here called Tech NQ, and we had a girl from Tech NQ. She was only year 10, and she came in and did a week's worth of work experience with us, and then she really enjoyed what she did. We gave her a little project, and it's like a 3D modeling sort of work, and she did a fantastic job for a year 10, And then she came back again in year 11, and she did 2 weeks work.
She got a taste of it.
Exactly.
Yes.
And then her perspective around sort of modeling and all that, it was fascinating. Probably her aptitude was around university, undergraduate year 3 aptitude, and we got really fascinated, and now sort of we are onboarding her.
Love it.
as a trainee.
There you go. It's a perfect mix and straight from high school. So how does that look when they are the digital natives and they're more familiar with the uptake of skills and when it comes to technologies and so on? But what about the thinking? What about the approach? I'm obviously a very big advocate of how design thinking fits into this, especially with integrating creativity into problem solving and not seeing failure as an end outcome. It's actually just a speed bump along the way and gives you better outcomes and so on. And the integration, use of empathy and knowing how to utilize those things. What are your thoughts on how design thinking plays a role within engineering?
Look, that's a really good question, and with the curriculum refresh or curricular refresh, I believe that element has to be embedded into our undergraduate studies, because, as you said, we got to in Australia we are very risk averse, but if we don't fail, we won't learn. So, but we got to fail fast.
Fail fast, fail forward.
Exactly. So, I believe that's very important, and there are a lot of young entrepreneurs that are coming out of the university. They're with the startup ideas and all that type of thing. That's something that we really got to promote. And not only entrepreneurs, like we need entrepreneurs with the organizations as well, and the design thinking and empathy mapping and customer led design and all that's really important. And we just got to train our graduates not only to be critical thinkers, but also creative thinkers. So I'm very strong on that. So we got to build in that element of creativity as a key graduate attribute.
I think that's music to my ears, because especially when it's an analytical industry like engineering, people naturally assume that creativity is not so much of a thing, left brain, right brain, all of those things. We don't really need to worry about those kinds of elements. But this new age Industry 4 requirements, I'm very happy to hear from a professional such as yourself that those skills are actually very much embedded into the foundation. So last thing I usually ask from all my guests is, what's your advice for students and graduates, especially if they're looking at this as their future career path in the next 5, 10, 20 years?
Look, I was sitting in one of the conferences, and I forgot the name, but one of the AI experts was one of the keynote speakers, and she said, looked into our eyes, and most of the audiences were civil engineers, and she looked into our eyes and said 80% of your jobs is going to disappear in next 10 years.
Oof.
So if you're just clicking your mouse and doing a mundane sort of stuff, then machine would be much better off doing that, and
without the human error, and
exactly
10,000 times faster.
Exactly. And then the engineers will be doing the final check and QA of that, rather than sort of clicking your mouse and sort of churning things out. So those engineers and professional will excel. Who's got the sort of things that we talked about. It's got creative thinking and problem solving, and who can sort of work together with the customers with empathy and find out solutions together with them. So co-create solutions. So those are the professional who will excel.
Yeah.
And all the rest of it, I think machine will definitely take over at some point.
Combine the thinking, those human elements, the problem solving, and combine it with the technology skills, you're in it.
Absolutely.
Perfect. Thank you so much, Govinda. I've learned so much personally, because this is an industry that's very closely related with architecture, so very personal to me as well, but gathered a lot of information. I'm sure the listeners took a lot from this as well. But lastly, if they want to learn more about what you do, LiXiA, Rockfield, or even engineering in general, how can they get in touch with you?
You can look us up on website, or you can get connected with me on LinkedIn.
Perfect, guys. Well, there you go. Make sure you guys connect with Govinda and reach out to learn more about the engineering field in advanced manufacturing. But otherwise, I've had a great time. Thank you so much.
Thank you. Thanks for having me.
That's it for today's episode. Now it's time to take action and build on the learnings to get inspired. First up, jump onto rashansenanayaka.com/podcast and check out the show notes, links, and other relevant learning materials from this amazing episode. Next, if you learned something new today, click that subscribe button and set yourself up to receive live notifications on future episodes, as well as more opportunities to learn from our amazing guests, brands, and speakers. Last but not least, it's time to have your say. Join the conversation and share your thoughts and feedback on today's episode with a review, all while joining many others with a 5-star rating for Inspiring Design with Rashan Senanayaka. Till next time.